Yeah, so I think we will have two parts of today's lecture. One part is about introducing you to some basic definitions and terminology of differential privacy, and that probably will just take the first half. And then the second half will be hear from each team, project team, reporting back to the group about what you have done for your project. So let's see, I have to make myself share screen. All right, okay, so the slides of the differential privacy lecture, I think I posted actually last week. We just didn't get the chance to talk about it. So if you go to the course website, you should be able to find it. And this, as you see, really coming from a total different angle of thinking about privacy protection, okay? And the lecture today, we'll have like a couple of more lectures about this. Well, we have 4 more weeks to go, but a couple of more hopefully about differential privacy. But the one today and most likely next week as well, as you see that it's not so much about doing data synthesis, okay? We're not dealing with what we have been doing so far, where we actually develop a model and then actually using, in particular, Bayesian models to generate or synthesize values from the posterior predicted distribution, okay? But rather, as you will see today and next week, that we're focusing on certain statistics, right? Summary statistics that some people might want to get out of the query, right? And then adding noise to those summary statistics that it's satisfying a particular, oh, okay, Ray is joining. Okay. Ray here. Okay. Welcome, Ray. I hope you are doing fine. We just got started, and so we are, yeah, so you will see that here we're gonna define formally what differential privacy is, and the material today and next week is mostly the traditional definition and traditional dealing with differential privacy, that we add noise through a certain distribution that will be satisfying the differential privacy guarantee, okay? But hopefully if we get the chance, or at least I can share with you some of the material that people are marrying the idea of synthetic data and differential privacy, that, as you can see that so far, oh, let me just get started so things will be included here. So in our class this semester, we've been talking about like synthetic microdata, right? We're looking at record level data and then thinking about how to use Bayesian methods, right? Bayesian synthesis models. We spent 2 lectures on that, and different ways to do it, what kind of variable you work with, gonna result in different type of modeling technique, right? And then also, what if you have multiple variables so you want to synthesize, then you will do it sequentially, things like that. And then we spend, as you can count, 5 lectures, I guess in total, or even 10, or even 6, I think, because last week we were still talking about, I think, risk evaluation and all that. Talking about how to measure the utility, right, of the synthetic data and then the risk of the synthetic data. So the focus before was we are driven by modeling, right? We're coming from the angle of maximizing the utility. And the reason why we say that is because, well, as you notice, that we develop the Bayesian models that are most suitable in the context that we're working with, right? And we are hoping to use the model to use the model to estimate the data as much as we can, right? And then in a way we're maximizing the utility, and that is why we call it, we're coming from the angle of utility, maximizing the utility. And then almost like risk evaluation comes as an afterthought, even though it is what is driving us to think about using synthetic data through modeling. But we model the data. In the process of modeling, we don't take any care about the risk itself, right? We're just thinking about modeling, and then from there, generating synthetic data. But then, of course, we not only need to evaluate utility, we also need to evaluate risks. And then, as we've been talking about for the past few weeks, the risk evaluation methods that we have been learning and practicing with, they make certain assumptions about intruder knowledge and behavior. And as you can see, in the previous few lectures, especially the most recent two, about the attribute disclosure. While we're making a lot of assumptions, and sometimes we have to make super conservative and strong assumptions, not because, well, we really want to be super careful about evaluating risk and then making sure that we get the upper bound or anything, but also in terms of computing, right? Like the worst scenario assumption that we had in the past, just now about the attribute disclosure risk evaluation, if you remember, was about we have to assume that the insurer knows everybody else except one record, right? And it is the record that we're working with, trying to evaluate. That is a very strong assumption, and it's there, just like we were talking about before, that it's not only about being really conservative, but also just to make the computation feasible. Because if you remember, we did the important sampling and all that. And if you relax your assumption a little more, saying that, well, maybe the insurer does not know all of the records, maybe you only know 50% of the records, then, well, as we know, you will have to either abandon important sampling altogether, or you will have to do some even maybe like parallelization and all of the other computing techniques, because otherwise it's just not feasible. Okay, so again, synthetic data itself, especially I think introducing the data confidentiality topic to people like us with certain Bayesian modeling background, I think is intuitive. It is sort of natural that if we can develop Bayesian models, we're just generating fake or synthetic data from the posterior predictive distributions, and we just need to make sure that we take care of the utility evaluation and the risk evaluation, okay? And however, inevitably, we have to make assumptions about risk evaluation, and that's why some people were not really happy about this whole approach itself, just because in some way, risk evaluation seems to be an afterthought, right? Like you sort of have to do it and you have to show it's good enough. But there's no way to guarantee that, say, I just don't, like say my release data does not compromise like privacy or confidentiality to a certain degree. Like how can you put like an upper bound of the risk that you're giving and or you're like exposing the synthetic data to? And that is what one biggest drawback of this approach. And for the rest of the semester, we're going to talk about from the other angle, right? From the risk angle, that approaching data privacy. And the method is called differential privacy. It actually came out, I think, thinking about now, it's almost 15 years ago. It was developed from the computer science research field. And I think even now, the majority of the research is still done, about differential privacy is still done in the computer science field. And a short introduction, it is a formal mathematical framework to provide privacy protection guarantees, okay? And the initial focus, which is, the initial focus of differential privacy, the whole field itself, is on summary statistics, okay? Not on actually a micro level data or tabular data. So you will see that we're adding noise, soonish you will see, we're adding noise not to actual data itself. We are adding noise to summary statistics, and we're making sure that the noise added version of the summary statistics provide privacy protection guarantee, okay? And in order to do that, we have to add noise in a random but smart way. And when I say smart, it's really just satisfying all of the underlying framework of differential privacy, okay? So the thing is, like I said at the beginning, there are people now trying to combine differential privacy and synthetic data, and that's what people now call differentially private synthetic data. And when we say synthetic data, of course, we're talking about the actual data, not summary statistics that are being released, right? So hopefully the last lecture or the second last lecture of this semester, I will be able to introduce you to some of the ideas, and especially thinking about it from a Bayesian perspective, okay? All right.